All right. Hey guys. Today I'm going to be presenting my ecological experiment called Ladybugs and Aphids. My name is Tiffany. I recorded this earlier and it was really slow and it was really bad. So you guys would have literally fallen asleep. So I'm redoing it. First of all, we're going to start off with explaining the ladybug. I'm going to try and do this a lot faster than last time, so bear with me. The ladybug that I will be focusing on is located in Central Valley. It was on the bank of the San Joaquin River. The scientific name is Cochinellide. I'm sorry if I butchered that. Um, that's what it looks like to me. But essentially, a ladybug is a beetle with a red or yellow domed back with black spots. I'm pretty sure most of you know what a ladybug is and looks like. Essentially, they are popular to farmers because they eat aphids and other plant eating pests. A ladybug can eat about 50 aphids per day, which is like quite a lot considering it's like a tiny little bug. And ladybugs are most active from spring until fall, so they're pretty dormant during the winter. I believe the one that we will be focusing on is a seven-spotted ladybug, which are native to Europe, but were brought to North America in the mid 1900s to control aphid populations. So that's why they're here in America. They can live in grasslands, forests, and along rivers. Then I'll be moving on to the aphid, which also is from the Central Valley in this case. It was on the bank of the San Joaquin River. Scientific name, Aphidiodea. Aphids are usually harmful to many host plants because they essentially suck the juices from the leaves and stems. So they're taking out all the nutrients from those leaves and stems, which can cause discoloration of leaves and even stunted growth. If there's a large enough infestation of aphids, they produce this waste product that is sticky and sugary, which will in turn help fungus grow in the plants. And that's not what we want when we're considering farming and agriculture. They also thrive in fairly humid environments, considering. So there's some pictures of aphids, cute little bugs, but very bad crops. Then moving on to just describing the ecological interaction and observation in and of itself. The video shows a ladybug crawling along a weed that is located on the edge of the San Joaquin River. These white aphids, the tiny little white aphids, can be seen lying in the crevices if you look close enough, which you won't really be able to see in this video, but they're like tiny little white dots all over everything. Those are the little aphids. And it's important to note that these grasses and weeds are really like about 2 feet tall. So the ladybug is kind of hanging out right in the middle. So here's the video of the ladybug. He's hanging out in that little bud, searching for some aphids. So that's that. Here's a little cartoon. You want to look at that for a second? I thought that was cute. Anyways, the ladybug naturally has bright red colors that tell a predator that they do not taste good. But this experiment will be testing the hypothesis that even though that is like their natural, defense mechanism from being eaten by predators, my hypothesis will kind of stretch into the idea of maybe they hunt under the coverage of taller grasses and weeds, therefore out of sight of predators. So, being that my hypothesis is ladybugs search for aphids at or around 1 to 12 inches above the ground on grasses or weeds. The prediction would be in order to avoid sight from predators, the ladybugs will search for aphids at a relatively lower altitude on plants and grasses. So to start this experiment, we'll need a tape measure, a plot of grassy weedy land, and 7 days. Important experimental variables. The dependent variable would be the average feeding spot distance from the ground. So that's what you're testing. The independent variable would be the height of the grass and weeds. So the grass and weeds that this ladybug and the aphids will be tested on. And then the control variable, the things that you want to keep the same, obviously, are the number of ladybugs and the environment. You want to keep those factors pretty much the same throughout each group. So here's a data table that will coincide with kind of the methods. You'll have 6 quadrats. So those are little sections that you can put in like a field, for example, which is what we'll be doing in this experiment. And over a matter of 7 days, you would kind of measure the average height of, which I will explain in the next slide. Average the height of the ladybugs on the grass and input that into the data table. So in regards to that table, the procedure would be to start off by separating a plot of grassy aphid-filled land into various randomly placed quadrats that are about 1 foot by 2 foot each. You don't want them to be too big because these are tiny little ladybugs and they don't really need that much space. So you'd have like 6 quadrats total. And then you want 60 ladybugs. So you would separate the ladybugs into groups of 10 each and then put them in each quadrat. And then over 7 days, every day, maybe around one set time in the afternoon, daily for 7 days, using a tape measure, just calculate the average height at which they are feeding. Then you can collect the data and input it into the data table, and then use ANOVA testing, which will help you to decide whether to either reject or accept the hypothesis. Here's just an example of what it would look like. You'd have 6 quadrats in a grassy field, and you would observe these little ladybugs hanging out on the weeds, eating aphids, and see where they are in relative to, the ground or whatever. And so essentially, this experiment would have a purpose in the sense of, an ecological perspective, because it can, maybe determine whether landscapes in the wilderness and crop areas should keep plants and weeds maybe at a certain height in order to lessen the aphid population and protect viable crop resources. Obviously, when you're done with this experiment, you can determine whether or not the hypothesis is rejected or accepted. And then if you want to, decide on like what could be improved on this experiment, you can obviously do it a very longer period of time, which could, bring more accurate finalized results. And that is my experiment. I hope you enjoyed. Thank you. Okay.